project by Rob by Ken Thompson. So it for 2007 and open source in 2009. So uh, it it's a statically typed language, meaning types are static. So it descended from C, so it has C-like syntax with garbage collection. So structural typing. So it means that, so in other language like say Java, so types are distinguished with its name. So let's say you created a new class called dog and the other one is cat. So even though the two classes are the same, so let's say they have like methods called, or they have fields called say arms. So they have arms. So even though they are the same in structure, they are not the same because they have different names. So in Go, if you have two, let's say structures called cat and dog, and they have a field called arms, and they both have a field called arms, so they will be treated as equivalent. So CSP style concurrent programming features. So in other language they use threads, so they use locks to protect resources. In Go, as I think the same with Erlang and Elixir, they use channel to communicate. So Go doesn't have threads, it has Go routines. So programming language of the year 2009, probably a hype. Yeah, it's the year when it launched. So okay, so reached 13th place 2010. So by June 2015, blah blah. So Google created this language to basically based on raw pipe to replace C++ because they have huge infrastructure that are hard to manage. So they created a language that would make it easier to look into code, make sense of it. So in C++, I've tried C++ before, and the syntax is not straightforward. So Go communities. So in Reddit they have dedicated subreddit for Go and Stack Overflow, and Go is open source. They're developing it on GitHub, and there's one gopher named Francesc Campoy. He's creating a series of great videos about Go. So better check that out. So what is Go good for? So a lot of companies have already transitioned to Go. So maybe they're just trying it. So from Java to Go. So Go is good for command line application. So if you don't know it, Docker is built with Go. If you know Ethereum, there's a client created with Go called Get. Okay. So web application. So if you are say coming from ASP.NET or Ruby, there are numerous frameworks, lots of them, and the more famous ones are Gin, Echo, Rebel. There's another called Iris, but developers don't like it because the creator of Iris is not giving credits to the external libraries that he's using. So if you're building microservices, so there's one called Go Micro and GoKit. So I like GoKit better because it gives you all the freedom to build your microservices from inside to outside. So if you like microservices, go use GoKit. And also good for API servers, so REST servers. Key value store, so there are key value stores created using Go called etcd, who have used etcd before. Yes, for and console for service discovery. Database, Cockroach DB, DocsDB, Dgraph, whatever. Cool. So Kubernetes created using Go. So why Go? So just a question: who among you have already used Go before? Nice. So why Go? Because it's simple and you can transition better coming from say C++ or Java background, C background, C#. You can transition easily with Go. Expressiveness. So when you see a line of Go, it doesn't give you obscurity. So everything is very expressive, very clear. So line by line. So speed. So speed is about Go is compiled, so speed is one of its features. So community, it has vibrant community. So lots of libraries are created for Go. So let's jump into one of the examples. Can you see that from the back? So all of Go programs are starting with package name. So this one is called package main because it's a binary. So you would compile it into binary, of course. So all of the programs starts with main package. So this is where you initialize everything. So there's also import statement. So on other languages, you have libraries. So in Go, you have packages. So say we import format or func, then net-http. So net-http contains all the HTTP related functionalities for building web applications. So this here tells Go that I want the root to display this text, hello meetup. So we declare here an inline function or anonymous function. So you can do it's basically like JavaScript function or callback. So and then we start it on port 9090. Okay, so localhost 9090. So that's the address. So let's try to run. Starting the server on port 9090 on localhost. it will just basically display hello. So then so you can also customize your or your multiplexer. So before we're using the default mux. So NetHTTP has default multiplexer somewhere in Go inside its code. So here we can customize it. So here we're creating a dedicated multiplexer. So say HTTP new serve mux. So we'll give you new multiplexer, and then so same as before. So we'll print hello meetup on root when you visit root localhost 1990. So pretty boring. So you can also customize the server. So before we're using default server. So here we can customize server. So you want to time it out, say in 5 seconds if and timeout. So boring. So say you want to display HTML pages. So in Go you're just reading file and then displaying it. So if you have so here we declare index func. So this is just HTTP handler func. So this is the signature for HTTP handler func. So you read the index file, then so in Go it doesn't have exceptions. So in other language they have exceptions, but in Go all error are values. So you can notice is here it returns a template and an error, and we check if the error is not nil, or if the error is not nil, it means there's something wrong with you reading the template file. So here we declare a struct or a class. So it's like a object on other language. So it has field code name. So create one, and so here we execute the index page, or take the file and take the object. So I will show you the template file. So that template file, so this will just replace the dot name. So that name here will be replaced with say my name, Steven. So we just print hello Steven, or whatever you put in here. Okay, so is everything clear? Then so what if you want to store data? So in Go there's one called MGO, or a package for handling connection with Mongodb database. So we declare a struct here called person. So these are tags. So when Mongo reads the person struct, it will know that the equivalent. So imagine you have a JSON called JSON. So it has person and it has first name and last name keys. So when you parse a JSON to Go, imagine this tag here are equivalent to those keys. So when you parse it, so it will be equivalent to the values of the struct. So okay. So here we create a connection to the Mongo database, then so create a session, then so So here we're inserting data to MongoDB. So we have, so I created a session for say database called meetup, then took the person's collection, then so we are inserting. Imagine this is a dictionary or map on other language. Okay. So imagine you have JSON here. So when you insert it to the Mongo database, so before you see Bison and you have first name, so you saw the JSON tags. So they will be equivalent to the values of here. So here, so let's forget about a struct first. Let's just insert a complete map or dictionary. So imagine you're just inserting JSON here. Then, okay. So let's. And when you want to read the data from JSON, from MongoDB, you just take the same collection and then issue some commands similar to MongoDB. So in MongoDB you have db that say collections that find, and then it will give you all the data inside that collection. So in MGO you also have the same almost the same syntax. So you have collection that find, and you pass in nothing to the collection, and that means give me everything. Then that's it. And here from the loop, we're saying here that whatever you read, put it into this person variable. So it's the same as the person's. It's an instance of the person struct, and then we're printing it, right? So that's basically it. And so an API server. Let's look into an API server. So in an API server, you can actually use that HTTP package for almost everything, but that would be tedious. So we're using external packages. So this one is called Go Kai or G, whatever you want to pronounce it. So we're using it to create an API server. So here we declare a new router, or it's like a multiplexer. So just the new serve max before, but here it's called router. It's called router because let's say someone from the web browser visits root. So it knows where, what function to call. So let's say someone from the browser visits hello, hello address, and it knows that it needs to call the hello function. So back to the router. So here we're using middlewares. So middlewares are executed before executing the, let's say, hello func. So it will execute logger, URL format, and setting the content type to JSON before executing the other functions, say hello func. So, okay. So when you use net HTTP, you would have to do everything, check the method if it's get or post or whatever. Here you just saying when I get request from /hello, just call this function. I don't like to I don't like other requests, so I just only want get. So that's just basically what we're saying here. And here we're using we're using regular expressions to match the, let's say you just want numbers for your IDs. So if say user enters string or whatever, yeah, it will not match. So the user will get 404 not found. So here we're just initializing a get and post. So other requests will be rejected when you visit /users and then say 1. So that's it. Okay. That's it. So I'm actually using this set of packages when developing my applications. So this one is a contrived example and really simple. The one that we're creating is much better than this. We actually separated the, say, models, and these models are not actually aware where they are stored. So you can have a model that are stored in, say, Postgres, others are stored in Mongo. So, okay, so frameworks and toolkits. So as I said, you can do almost everything using the standard library, but it will be tedious and so another choice is to use frameworks that are created by the community. So you can use Rebel for full-featured web framework. It has hot code reload, other packages for connecting to databases. It's a complete MVC framework. Gin is almost the same. Echo is a minimalist one, so it doesn't have all the features, but the basic idea of Go is you take small pieces of things and you combine them into a big application. So that's how it is. So other people prefer to use different packages and then combine them into one application. But others coming from other backgrounds, say ASP.NET, they might prefer to use full-featured framework. So Gorilla Toolkit is one of the packages that are separate. So you have router, you have, so you can just check it out. So Gokai, like the one that I have shown you earlier, so it's one of my favorite package. GoKit for microservices, I personally used GoKit before, and it's better than GoMicro because it lets you build things from top to bottom. So you know everything that happens in your code. Unlike Micro, everything is abstracted from you. You don't The disadvantage of using frameworks is the choices are already made for you. So let's say you want to use other libraries or packages for connecting to database. You can't have that on other frameworks. So that's why in Go, the mindset is take small packages and then combine them into one application. So that's what the path that we took. So there's also a GitHub repository called Awesome Go, like Awesome Python, Awesome Elixir. I think there's also Awesome Elixir that are dedicated to list all the packages by categories. Let's say you want web application, web frameworks. So they have list of web frameworks, routers, etc.
2 minutes. 2 minutes. 2 minutes.
So web development when in Go is awesome because you can create big applications by combining different packages, and the code is clean and very straightforward, very simple, and yeah, it has a vibrant community, and Go is backed by Google. So that's it.